Hi, I'm Miss Van Loan, and in this video, we're going to complete Module 4, Lesson 6, Independent Practice. Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper, and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's get started. Module 4, Lesson 6, Independent Practice. Number 1, the two quadrilaterals shown below are similar figures. What is the value of x? So similar figures means that they are proportional to one another. Remember we were talking about proportional relationships before? So that means they have the same shape. They are just bigger or smaller. They're both facing the same way. They have some measurements given. And because they're facing the same way, it's easy to see that 4 millimeters, this 4 millimeter side here, corresponds, and that's actually a vocabulary word. These are corresponding sides because they are the same side, but for the smaller one or for the bigger one. There are a couple different ways to solve this. My favorite one is to set up two equal ratios and solve for the missing x. So for example, we can set this up like the 4 side compared to the 6 side is going to be equal to the 6 side compared to this x side. It looks like this. 4 goes to 6, just like 6 goes to the x. When you have two equal fractions like this, and there's nothing else on that side, nothing else on this side, just two equal fractions, you can take the bottom from one side, multiply it to the top of the other, and vice versa, and write out a new equation without the fractions. So it looks like this. X times 4 is going to equal 6 times 6 on that side. So then we'll rewrite this. This is 4x's is equal to 6 times 6 is 36. Now we solve this just like we solve any other equation for x. We're going to separate the sides, and we see that we have 4 x's on this side, so we're going to divide by 4 to get what 1x is equal to. 36 divided by 4 is 9. So that side there is 9 millimeters. So x equals 9 millimeters. Number 2, the scale on the state map of Maine below is 1 centimeter equals 100 miles. Estimate the length of time it would take you to drive from north to south through the longest part of Maine if you drive at 55 miles per hour. Okay, so I printed this out because I want to show you physically how I do this. Hopefully, in most circumstances where you are having to measure like this, you will actually have a tool like a ruler that you can actually hold up, measure it, and it depends. So right here, how I have this printed out, it looks like it's about a centimeter, but if it was on a computer screen, it might not be a centimeter. It might be an inch if you zoom in on it and make it like really big. It might be half a centimeter if it's like really tiny if you're looking at it on your phone. And oftentimes what I'll do is I'll try to use my pencil. Usually I have a yellow pencil, and I'll just kind of like stick my thumb in my pencil and like measure how big it is. In this case, I might like push the lead out and see how big the lead is and compare it. So that's about how big it is. But then I would need a second pencil in order to like measure this from this longest part up here. So I'm going to start at the very tallest peak right here, and I'm going to go straight down north south, like right around here. So I think it's going to go through here and through here. It's saying if you drive from north to south, it doesn't say from northeast to southwest. It says north to south. If I was driving from here, northeast to southwest, then that's when I would do this one. I'm not. I'm going north to south. And this is if I don't have a ruler, right? If I don't have a ruler, I'm trying to use my pencil or maybe my thumbnail if I'm looking at it at a computer screen. So there was 1, 2, 3, and 4. So I got 4 lengths in here, right? I measured my lead, or like I said, if it's a yellow pencil, sometimes I'll just like dig my thumbnail in it to like figure out, to have this to compare it to. I could, since this paper is something extra that I printed out, I could just rip this off and then move it over here. I could rip off a piece of paper from here and then copy down the little scale. There's lots of ways that you could do this. You have to kind of MacGyver it. So you could always just like rip off a little corner of your test and do it. 3, 4. Again, you just kind of have to look and see what are the tools and resources that you have available to you. If you are taking a state test and you're working on the computer, I think they have like a tool that you can bring out and like move and actually measure it. I'm not sure, but I think there might be electronic tools like that. Just look around, play around with the menus. You can totally do that. I got 400 miles. North to south, 400 miles. Estimate the length of time it would take you to drive from north to south if you drive at 55 miles per hour. So 55 miles per 1 hour, and I'm going to be doing that over the course of 400 miles. So all I have to do is take 400 miles and divide it by 55 miles per hour to figure out how many hours it's going to be. 400 divided by 55 equals 7.27 repeating. Let's say 7, and we'll just round it up to 3. 7.3 hours. Number 3. The scale used to create a blueprint of a new house is 0.5 inches equals 1 foot. If the dimensions of the bedroom are 9 inches by 7.5 inches on the drawing, what is the area of the actual room? So I've written down the information. A 1/2 inch in the scale drawing is 1 foot in the actual house. So I've got the bedroom here, and we're going to label it with 9 inches on one side and 7.5 inches on the other side. And so a 1/2 inch is equal to 1 foot in real life. A 1/2 inch on the drawing is equal to 1 foot in real life. So what is the area of the actual room? So first of all, we have to find what the actual house measurements would be, and then we have to multiply them to find the area of the bedroom. Remember, the area is all of this. So it'll be feet squared because we're going to multiply the two sides together to get the area. So a 1/2 inch goes to 1 foot. Doesn't that mean we would just multiply by 2? right? 0.5 times 2 would be 1. So that makes this really easy. We'll just multiply this times 2 and we get 18 feet. We'll multiply this one times 2, and 7.5 times 2 is 15 feet. So the real dimensions of the actual house are 18 feet by 15 feet. So then we multiply those together to get the area. 18 times 15, 270 feet squared, because we are doing area. Let's do number 4. A map has the scale 3.5 inches equals 20 kilometers. The distance between two landmarks on the map is about 2.4 inches. What is the actual distance between the landmarks? Round your answer to the nearest tenth of a kilometer if necessary. I printed out the little table here so we could see this, and it's telling us that the map distance is in inches and the actual distance is in kilometers. And 3.5 inches on the map equals 20 kilometers in real life. So what would 2.4 inches on the map equal in real life? We can do this one the exact same way that we did number 1, by setting up equal ratios and then doing cross multiplication to solve for the missing piece. And that's what we're going to do. So 3.5 corresponds to 2.4, just the same way that 20 corresponds to our missing value, which we will call x. Let's cross multiply, and we'll have x times 3.5 is equal to 2.4 times 20. We'll rewrite this. 3.5x is equal to 2.4 times 20. $48. And now we can solve this. Separate the sides. I see I have 3.5 x's over here, and so I'm going to divide by 3.5. I'll have just x on that side, and now 48 divided by 3.5, and that equals 13.714 blah blah blah. And this says round your answer to the nearest tenth of a kilometer if necessary. So we're going to round to the 7. We're going to round this number. 1 makes the 7 stay the same. So 13.7 kilometers. Okay, let's do number 5. A basketball coach painted a copy of half of a basketball court on a chalkboard so that she could diagram plays at halftime. The actual dimensions of the court are 42 feet long and 50 feet wide. If the coach's diagram is 22 inches long, how wide is it? Round your answer to the nearest tenth if necessary. The question is giving us some information. It says that the coach drew on a chalkboard, and that's what this picture is. And we've got the half court, and it's 22 inches long on the board. Now, in real life, the question is telling us that the court is 50 feet wide and 42 feet long. So this is what we're looking for. We don't know what the width is in inches on the chalkboard, but in real life, it's 50 feet wide. It also is telling us that it's 42 feet long, and that doesn't really make sense for the court to only be 42 feet long. So I'm wondering if the 42 feet is just the half court, that the half court is 42 feet long. I looked it up, and a standard basketball court is closer to 92 feet long. So that would make more sense. And then half of 92 feet would be 47 feet. So maybe if the courts at the school are just a little bit shorter, that happens sometimes just to fit it into the space. So it could be that the full court is then going to be 84 feet long. That's what my guess is, because it doesn't make sense for the length of the court to only be 42 feet, but the width is 50. That would make sense for the half court. So that's what I'm going to go with. I'm going to go with the half court is 42 feet long and 50 feet wide. So the half court is 22 inches long on the chalkboard and 42 feet long in real life. And then the width is 50 feet and the width is unknown inches. So let's set this up as 42 feet compared to 50 feet. 42 feet compared to 50 feet is going to correspond to the 22 inches, right? This is the similar side, the corresponding side of the court. Okay, so that's our unknown, that's our x. Let's go ahead and do some cross multiplication here. X times 42 equals 50 times 22. And we'll go ahead and rewrite that as 42 x's is equal to 50 times 22, 1,100. And now we will solve it. There's 42 x's, so we divide by 42. And x is equal to 1,100 divided by 42, which equals 26.19 inches right there. And if we think about it, that makes sense because 42 is a little bit less than 50. So the 22 should be a little bit less than whatever this side is. So 26.19, that makes sense. It says round your answer to the nearest tenth if necessary. Okay, so we've got to round that up. 9 makes the 1 go up, so 26.2 inches. Number 6. An architect made the rough sketch of the bedroom in a new house shown below. If the scale used to create the sketch is 0.25 inches is equal to 1 foot, what is the actual length of the room? So the scale is that 0.25 inches is going to equal 1 foot. And I already can tell that if we multiply 0.25 times 4, we will get 1. So I know that the scale here is that we have to multiply by 4. Multiply by 4 to get to 1 foot. We have a sketch of the bedroom. This says 5 inches. What is the actual length of the room? So we're going to take this 5 inches and multiply it by 4 to get the actual amount in feet. So let's multiply by 4 and we get 20 feet. If it wasn't as easy to solve, if it wasn't 0.25, times 4 is equal to 1, we could always set it up as a pair of equal ratios like this. 0.25 inches is to 1 foot as 5 inches is to X number of feet. Notice how the feet are both on bottom and the inches are both on top. So it's same corresponding. Then we cross multiply and we would get 0.25x is equal to 1 times 5 is 5. And then of course we divide by 0.25 to both sides. And 5 divided by 0.25 is equal to 20. So it still works doing it this other way. Use either way. You can do whatever works for you. As long as you're showing how you get the answer, then it should be fine. Number 7. The distance between two cities is approximately 6.5 kilometers. Using the scale shown in the table, how far apart will the two cities appear on the map? Round your answer to the nearest tenth of an inch if necessary. So the distance in real life between two cities is 6.5 kilometers. So in real life, 6.5 kilometers apart. Using the scale shown in the table, so the scale is 2 inches is equal to 4.5 kilometers. How far apart will the two cities appear on the map? And then round to the nearest tenth, if necessary. So let's set up our equal ratios. So 2 inches is to 4.5 kilometers as 6.5 kilometers is to some number of inches. So this is why I pointed out the units on the previous one. We've got to make them corresponding. So the kilometers now is going to go on the bottom. 6.5 kilometers so that they are corresponding. And then we are looking for X number of inches. We'll still solve it exactly the same way. We're going to cross multiply. 6.5 times 2 is equal to 4.5 times X. 6.5 times 2 is 13. And we'll just bring that down. We'll divide by however many x's we have, which is 4.5. Divide on both sides by 4.5. 13 divided by 4.5 is equal to 2.8 repeating. And then we just have x on that side, so 2.8 repeating. So the next 8 is going to cause this 8 to round up because we're rounding to the nearest tenth. So this is 2.9 inches. Number 8. An artist is building a model of the pyramid shown below using dimensions that are half those of the original pyramid. If the original height of the pyramid was 13 feet, what will the height of the model be? Round your answer to the nearest tenth if necessary. I almost feel like we don't even need to do a whole lot of math, but I still feel compelled to at least show it to you. So if we've got this pyramid and the height of the pyramid is 13 feet, and an artist is building a scale model that is half the size, so times 1/2, the new one is going to be half of that. So what's half of 13? 6.5 feet. Okay. Easiest one of the bunch. Number 9, a picture of a rocket in a physical science book is 3 inches tall on the page. If the scale of the picture is 1 inch corresponds to 40 feet, what is the actual height of the rocket? We have a rocket, and please excuse my drawing. And okay, so we have a rocket, and it is 3 inches tall, and 1 inch corresponds to 40 feet. We're just going to multiply by 40 to get the height of the real one. So 3 times 4 is 12, put the 0 on, and we have 120 feet. I guess 8 wasn't the easiest. 9 is easy too. Okay, number 10. A toy maker wants to build a dollhouse that is an exact model of the toy shop. A rectangular room in the toy shop has the following dimensions: 12 feet by 9 feet. Using a scale of 3 centimeters corresponds to 1 foot. What are the scaled down dimensions of the room? It says 3 centimeters equals 1 foot, but we can write it the other way, that 1 foot is equal to 3 centimeters. So if we have 12 feet, we just multiply that by 3 to get the number of centimeters, which would be 36, because 12 times 3 is 36. And the same thing here, 9 feet times 3 will equal 9 times 3 is 27 centimeters. If the scale was a little bit more difficult, I mean, all 8, 9, and 10, all of these were really easy because it was a comparison to 1. But if they're not, we can always set up something like this. Like, let's say it was 3 centimeters to half a foot, then you would put half a foot, 0.5, and then you would say what you have and what you're looking for. So I have 12 feet, and I'm looking for centimeters, so that would be X. And then you can multiply it. So if we did it using cross multiplication, where we have our ratio and then the ones that we're looking for, we can still get the exact same answer. Okay, I hope you have a fabulous day, and this concludes all of the independent practice for this class. Please let me know if you still have any questions, if anything was unclear, and I welcome your feedback on these videos. If you have any tips, anything that would make this better for you so that you can understand the math better, please let me know. I'm open to that, and have a fabulous next year.